All right, let's talk about something truly wild, the story of Oumuamua. Back in 2017, this thing showed up, and it became the very first object we have ever detected visiting our solar system from another star. And almost immediately, it sparked a debate that is still pushing the absolute boundaries of science. I want you to just think about this for a second. For all of human history, literally everything we've studied in space has been part of our own cosmic neighborhood, our solar system. And then, in 2017, that all changed. Something new arrived. And right from the get-go, it was crystal clear that this visitor, well, it wasn't playing by any of the rules we thought we knew. It was first spotted by the Pan-STARRS telescope out in Hawaii, just a tiny little point of light streaking through their data. And the name they gave it? Oumuamua. It's a Hawaiian word, and it's just perfect. It means a messenger from afar arriving first. So, how did this messenger immediately stump some of the smartest people on the planet? Well, the mystery really began with the very first clues, the initial observations that started building this incredibly strange profile. The first jaw-dropping fact was its speed. At its fastest, Oumuamua was clocked at an incredible 196,000 miles per hour. Now that isn't just fast, that is way past our sun's escape velocity. That speed was the smoking gun that proved it wasn't from around here. It was just passing through, and it was absolutely destined to head right back out into deep space. So, as astronomers are tracking this little dot of light, they noticed something super bizarre. Its brightness was changing a lot. And I mean a lot, by a factor of 10 every few hours. This was a huge clue. It basically screamed that the object had to have a really extreme shape, unlike any asteroid or comet we had ever laid eyes on.
At first, this led to that popular image of a long, skinny, cigar-shaped object. But as they crunched the numbers and refined the data, a totally different picture started to emerge. The way it was tumbling and reflecting sunlight pointed to a shape that was much more like, well, a flat disk or a pancake. Now, both of those shapes are incredibly weird for a natural object, but the data seem to favor the flat one.
So let's just recap the weirdness file here. We've got an extreme shape, a chaotic, tumbling rotation. Its origin point was also weird. It seemed to come from something called the local standard of rest, which is kind of like a cosmic parking lot where very few stars hang out. And maybe most important of all, despite behaving a bit like a comet, it had no visible tail. None. But all of that was just the appetizer. The main course of this entire mystery, the thing that truly divided the scientific community, was the detection of a very gentle but completely undeniable push. When scientists mapped out Oumuamua's path with unbelievable precision, the math just didn't add up. The data was showing a clear deviation. It wasn't following the exact path that the pull of the sun's gravity said it should be on. Something else was giving it a nudge. What the data showed was that Oumuamua was accelerating just a tiny bit away from the sun. It was like a car coasting downhill that, instead of slowing down from friction, was mysteriously speeding up. Some kind of non-gravitational force was definitely at work. And this, right here, became the central question. The question that has launched, 1,000 scientific papers and sparked one of the most fascinating and heated debates in modern astronomy. What was giving Oumuamua that little extra push?
Okay, let's play detective. First, we have to explore the case for a perfectly natural explanation. Science always looks for a known cause before jumping to wild conclusions. And it turns out there's a really common phenomenon that pushes objects around in space. It's called cometary outgassing, and it's the go-to explanation for this kind of thing. As a comet gets close to the sun, its ices heat up. They turn directly into gas and shoot out in jets. It acts just like a tiny set of rocket thrusters, pushing the comet and changing its path. It's a process we understand really well.
But this simple, elegant explanation ran into a huge, massive problem. If Oumuamua was outgassing enough to actually change its trajectory, then all of that gas and the dust it kicks up should have formed a visible cloud, a coma, or a tail. So, where was it?
And trust me, they looked. They pointed the world's most powerful telescopes right at it, staring at it trying to find any hint of that dusty cloud that should have been there. What do they find? Nothing. Zero. There was absolutely no evidence of outgassing, even though the object was clearly being pushed by something.
This is where scientists really had to get creative. They started proposing some other, more exotic, natural ideas. Maybe it was a cosmic dust bunny, this super fluffy, porous object 100 times less dense than air. Or what about an iceberg made of pure solid hydrogen? Or maybe a chunk of nitrogen ice that got chipped off some distant Pluto-like planet? But the thing is, each one of these really clever ideas has its own major scientific hurdles that make it pretty unlikely.
So, with all the natural explanations struggling to fit the evidence, a much more provocative hypothesis got put on the table. What if that push wasn't natural at all?
This idea relies on a totally different force: solar radiation pressure. It sounds like science fiction, but sunlight itself actually exerts a tiny physical push. It's normally so small you'd never notice it, but, and this is the key, if an object is incredibly thin and lightweight, but has a huge surface area, like a sail, that gentle pressure from photons can actually be enough to accelerate it.
The contrast here is just stark. A typical comet gets pushed by its own gassy jets, and you see a tail. Oumuamua was also pushed, but it had no tail at all. That discrepancy is the entire heart of the argument that maybe, just maybe, we were looking at something other than a natural rock.
Harvard astronomer Avi Loeb really became the public face of this idea. He reasoned that if you rule out the rocket effect, because there's no visible exhaust, the next logical explanation for a push that gets weaker as you move away from the sun is the pressure of sunlight itself. And for that to work, the object had to be artificially thin. And look, this isn't just a theory. We've actually seen this happen before. In 2020, the very same telescope that found Oumuamua spotted another object, 2020 SO, that was also being pushed by sunlight with no tail. And you know what it was? It was a discarded rocket booster from a 1966 NASA mission, a thin, lightweight, artificial object. It was real-world proof that we can identify technology just by the way it moves.
So where does that leave us today? Well, we have two competing sets of explanations. One is natural, but requires us to imagine some exotic object we've never seen before. The other is artificial and incredibly provocative. The truth is, the mystery is still wide open. And here is the final, crucial twist in the story. When scientists actually measured the Oumuamua's acceleration, it was perfectly normal. The amount of push it was getting was totally typical for a comet in our own solar system. It's just the cause of that push, that invisible mechanism, that remains a complete mystery. And this is the big reason why most astronomers still lean towards some unknown natural cause.
And so we are left with this absolutely profound question. Was this messenger from afar just a new, bizarre type of natural object? One that will force us to rewrite our textbooks on how planetary systems actually work? Or was it something else entirely? Was Oumuamua our first fleeting glimpse of technology from beyond our solar system? The object is gone forever, but the question, that remains.